In this video, I'll show you how to control analog RGB LED strips with an Arduino. These LED strips let you add cool LED lighting to many of your Arduino projects. Note that in these analog strips, all of the LEDs in the strip will always be the same color. You cannot control them individually. You can buy individually addressable digital LED strips, but those are a topic for a different video. Let's turn off the LEDs and turn on the lights so we can take a look at the hardware and how this is all wired to the Arduino. The first thing we're going to do is look at the LED strip itself. So you can see that this is a strip with LEDs mounted on the surface. You can buy many different varieties of these online with different numbers of LEDs per meter. Some have an adhesive backing so you can stick them to whatever you're building. Some have a weatherproof or waterproof coating on the front, so you can see this strip has this clear plastic coating over the LEDs, whereas this strip does not. So you have to read the description and figure out exactly what you are buying, and again, remember this tutorial is for the analog strips, not the individually addressable LED strips. Make sure you read the description and know what you're buying because they look the same. Let's zoom in and take a closer look at the strip itself, and you may notice that every 3 LEDs along the length of this strip, I have these metal tabs with the labels plus 12 volts, green, red, and blue, and those are going to be your external connections to the Arduino, but wherever you have these tabs, you can actually cut the strip to length. So you usually buy these, they come in a spool that may be a few meters long, but you might not need the entire length for your project, or maybe you want to cut them up and control them separately. So anywhere you have these tabs, you can cut the strip to length. Don't cut in between those, so I wouldn't want to cut here or here. You want to cut along this indicated line where if you flip it over, you see those metal tabs are also accessible on the back of the strip. And those tabs are where you are then going to need to solder wires to connect to your Arduino. So if I go down to the end of my strip here, you see I have soldered 4 wires, 1 to each of those tabs, and then wrapped it in heat shrink tubing. If you don't have access to a soldering iron and heat shrink tubing and a heat gun yourself, you can buy these strips pre-terminated or pre-attached with wires. Again, you just have to read the description and look at the pictures and be careful with what you're buying online. So if you're going to be cutting them to length and you need custom lengths, you'll probably need to solder your own wires, but if you just look online and find a length that you need that comes pre-soldered with wires, then you can skip the soldering yourself. You will need to be careful with how you color code those wires to avoid confusing yourself later. If you have worked with electronics and Arduino before, you may know that red is usually used for positive voltage from your battery, but sometimes you might also use it for the signal for a red LED. So in this case, I have used red, green, and blue for each of the corresponding LED colors. And I've decided to use black for positive, even though black is usually ground. Again, the colors don't actually change how the wires work. It's just the convention and keeping track of how everything is connected. So you can use whatever convention you want. But for purposes of this video, I have red, green, and blue for the 3 LED colors. And then black is going to be my positive 12-volt connection to power the strip. Since I mentioned 12 volts, now is a good time to talk about power. These LED strips are very bright. They have a lot of LEDs. They require too much power to just power them directly from your Arduino like you would do if you're just getting started out with a couple LEDs on your breadboard. So you are going to need a wall adapter to power this. And again, you need to read the description for your LED strip, but most of them require 12 volts. So you may have a drawer of these things laying around from various appliances that you've accumulated over the years, or you might need to buy a new one online. But if you have them at home, you need to zoom in and check on the label. So I'm going to zoom in here. And what you want to check when you are looking at the label on one of these is the output. So it'll say something like DC 12 volts. If it's a different voltage, it might say 5 volts or 9 volts. So make sure that the voltage here matches the voltage needed for your LED strip, and then you also want to check the current, which is measured in amps. So this is a 3 amp power supply, and the amount of current drawn by your strip is going to depend on the length and the number of LEDs. So again, you will need to read the specs for your LED strip. It might tell you how much current is used per meter or for the entire strip. Make sure your power supply has enough current to power the number of LEDs you need. So even if the voltage is high enough, if it's 12 volts, if it's only a very small amount of current, say a couple hundred milliamps, then it might not be enough to power your full strip. 3 amps is a pretty beefy supply, so I should be okay here, but again, you need to check compatibility of both voltage and current before you decide to use the power supply with your strip. The other thing you will need to consider is how you are going to connect the power supply to your breadboard. These power supplies are usually terminated in a barrel plug like this, and you obviously can't plug that directly into your breadboard, but you can buy adapters like this one that let you plug the barrel jack in on one end, and then it has 2 screw terminals on the other end where you can attach jumper wires to then connect to the breadboard. So you need to make sure that the dimensions match. So you'll have to, again, when buying your power supply, look at the dimensions of the barrel plug, or if you have one at home, you'll just have to measure the diameter, and then again, look at the diameter of the adapter when you are buying it to make sure these fit together. That is then going to let you connect your power supply to your breadboard. The other option, if you don't care about keeping the barrel plug attached, is you can just cut this wire and strip them, and then you'll have access to the positive and negative wires. These are going to be stranded and flexible, so you can't easily plug them directly into a breadboard, but you could solder solid core wires directly to the stranded wires, and then you could plug them directly into the breadboard. But again, if you do that, you're losing the barrel plug, so if you want to keep the barrel plug, you should buy one of these adapters instead. Next, let's zoom in and take a look at how everything is wired on the breadboard. Now, if you want to control the 3 colors of your LED strip independently, you are going to need 3 transistors. These transistors here are called N-channel MOSFETs. Don't really worry about exactly what that means. Conceptually, you just need to know that these allow you to control a higher voltage or higher power load, such as your 12-volt LED strip, with a lower voltage signal from your microcontrollers. So the digital I/O pins on the Arduino are only 5 volts, and they cannot provide enough voltage or current to power that LED strip directly. So what the transistors let us do is use that lower power control signal from the microcontroller to control something higher power like a bunch of LEDs or a motor. Each of the MOSFETs has 3 pins. If we look at them from the front, so the writing is facing us from the left to right, those pins are the gate, drain, and source. So we are going to put these in the breadboard such that each pin has its own row. It's important not to put these in the breadboard like this because all of the holes in that row are connected. So if you do that, you are shorting all 3 pins of the MOSFET together. So it's important to put each of those pins in their own row. And then the first connection you're going to make with each one is to connect the source to ground. So the rightmost pin, or pin number 3, I'm going to use a jumper wire to connect that row of the breadboard to the ground bus of the breadboard, which is going to have a common ground with the Arduino. So you see I have a jumper wire connecting ground on this side over to ground on this side, which is then connected to the ground pin on my Arduino. So it's important to make sure that your entire circuit has a common ground, even though we're going to have that external power supply connected. So later on, I'll talk about how we want to make sure we don't short circuit the 12 volts from our power supply to the 5 volts from our Arduino, but you need to make sure the entire circuit has a common ground for everything to operate properly. Next, I had removed some of these wires so things weren't too cluttered here to begin with, but we're going to start reconnecting them. We are going to connect jumper wires from I/O pins on our Arduino to the leftmost or gate pins of the MOSFETs. And again, I have color-coded this, so I have red, green, and blue for each of the wires respectively. So I'm going to take a red jumper wire, plug it into same breadboard row as the gate pin of my first MOSFET. Green, I'm going to go to the gate pin of my second MOSFET. And blue, I'm going to go to the gate pin of my third MOSFET. And over on the Arduino, we'll talk about this later when we get to the code, I need to make sure I have selected pins with PWM, or pulse width modulation functionality. Those are the pins with this little squiggly signal next to them. Those are going to let us use the analog write command to change the brightness of the different colors, as opposed to digital write, which would only let us go between fully off and fully bright. Analog write is going to let us dim the colors separately and mix and match them to make different colors. So again, recapping on the MOSFETs so far, I have the source pin, or pin 3, the rightmost pin of each one connected to ground, and the gate pin, or pin 1, the leftmost pin of each one connected to a PWM pin on the Arduino. Next, I'm going to set up my power connection. So I have this barrel jack adapter that I'm going to plug my 12-volt power supply into. I have the negative wire from that going directly to ground on the breadboard, and I have the positive wire going to a switch, which is then connected to the positive bus on this side of the breadboard. So the switch has 3 pins. I pull that out there. 3 pins, 1 in each row of the breadboard, and I am leaving one of those pins unconnected, so the leftmost pin is unconnected. The rightmost pin is connected to positive from my barrel jack adapter, and the center pin of the switch is then connected to the positive bus. So when the switch is down in this position, the center pin is just connected to an empty row on the breadboard, so there's no power. When the switch is up in that position, this row is connected to the positive wire from the power adapter, and I have 12 volts on this power bus. But as I mentioned earlier, it is important not to short circuit that 12 volts to 5 volts from the Arduino, so I do not have a jumper wire connecting the 2 power buses on opposite sides of the breadboard. The final thing I'm going to do here is take the wires from my LED strip and plug them into the middle or drain pin, or pin number 2, on each MOSFET. So I'm going to take my red wire, plug that into the middle pin here, green wire, plug that into the middle pin here. Whoops, and I'm going to be careful that I don't start yanking wires out because this gets a little messy. Green wire there, blue wire here. So those are going to be my 3 pins that draw current through the LEDs and then through the MOSFETs using the control signal from the Arduino. And then finally, I have my power wire, which again, I used black not to get it mixed up with the red LED, but I am going to put that in the power bus. So remember, this is 12 volts, it's not ground. Don't get confused with the color coding I used here. This is the wire that's going to power the whole LED strip, so I'm going to plug that into the 12 volt power bus on this side, not 5 volts from the Arduino. So again, red to red, green to green, blue to blue, and then whatever color you decided to use for your 12 volt power goes to your power bus. And now your LED strip has both power and a control signal for each of the colors. So when I fire the Arduino up, it should start fading through different colors like I demonstrated at the beginning of the video. One more quick note about the circuit here. You might be wondering where the resistors are. If you have built circuits before using individual LEDs like this, then you might know that you have to include a current limiting resistor in series with the LED to prevent it from burning out. And if you are not familiar with that, we have a tutorial about it on our channel linked in the description of this video. But you might notice that there are not any resistors included in the circuit I built here. That is because the resistors are actually built into the LED strip. So if you look closely, you will see these little black rectangles here. These are what's called a surface mount resistor. They're called surface mount parts because they are flat and just sit on the surface of the circuit you are building, as opposed to through-hole parts like this resistor, which have wires that are designed to go through a hole on a circuit board or into the hole on a breadboard. So, long story short, you do not need to include these separate external resistors when using these LED strips like you would when working with individual LEDs, because the resistors are already built in to the LED strip. So I've connected my power, and what you can see here is that the LED strip is automatically fading through different colors. So let's now switch over to the computer and take a look at the code that makes this happen. Now we will switch over to the Arduino IDE and take a look at the code for the color fading. This is based on a nice tutorial available from Adafruit. First, we are going to define constant variables for the pins used for the LED control signals. Remember that these have to be PWM pins. Next, we are going to define variables we will use to control the brightness of each color and initialize them to set our initial color. So I am going to start out with red at 255, which is the maximum value for analog write, and then green and blue at 0. So we will start out with the LEDs at red. A crash course in RGB color mixing here is that, again, you have 3 different colors, but depending on the levels of the different colors, you can create other colors. For example, you can combine red and green to make yellow. Note that additive color mixing with light is different from subtractive color mixing that you get with pigment or mixing paint. Again, that's sort of a topic for a different video, so I'm not going to go over it here. but again, you can mix R, G, and B values to create other colors. Next, we have a variable for the delay that is going to control the speed of the fade. And then we move on to the setup function where we set our control pins as outputs and then use the analog write command to write that initial starting color. We are then going to initialize serial communication, which will allow us to print the RGB values out to the serial monitor so we can see them changing. Then in the loop function, we are going to use a series of for loops to fade from one color to another. And again, this is a bit of a crash course in RGB color mixing. For example, we are starting out with red, which has an RGB value of 255.00, and we want to switch to yellow, which has an RGB value of 255.255.0. So that means we need to keep the red value constant, that stays at 255. We keep the blue value constant, that stays at 0, but we need to increase the green value from 0 to 255, and that is going to gradually fade us from red to yellow. We can do that with a for loop, and you don't need to worry about all the exact syntax here. You can just copy what I have for your code. This for loop changes the variable g from starting out at 0 up to 255, incrementing it by 1 at a time. So that's what this for g equals 0, semicolon, g less than 255, semicolon, g plus plus means. Again, you can just copy that. Don't worry about the exact syntax. That's going to take g from 0 up to 255 to get us full brightness for our green. Within the loop itself, we have 3 lines of code. First is the analog write command to write that new g value or brightness value to that pin. We then have a function to print out the RGB values. So rather than copying and pasting those lines of code inside each for loop, down at the end of my program here, I have a print values function that's going to print out my RGB values. We will see that demonstrated in the serial monitor when I run the code. And then finally, we have a delay command, which again is going to control the speed of the fade. The longer or larger you make that delay variable, the slower the fade will be. We then repeat this process to fade between different colors. And of course, you can choose your own order here. You don't have to do it in the same order I did, but next up, I have it fade from yellow with a value of 255.255.0 to green, which is 0, 255.255. So in this case, we need to decrease the red value from 255 to 0 while keeping the other two values constant. And again, we can do that with a for loop. The difference in this case is that the R variable starts out at 255 and goes down to 0, and we subtract 1 from it in each loop, so that there we have R minus minus instead of R plus plus. But then within the loop, we have the same 3 lines. We have an analog write command to write the new R value to the red pin. We print the values out, and then we have a delay to slow down the fade. I won't read every single one of these, but you can see that I then repeat these loops to repeat the process, fading from green to cyan, then cyan to blue, then blue to magenta, and finally magenta back to red, and then we repeat the loop. So what I'm going to do now is increase the delay a bit so this is a little easier to see, upload the program, open my serial monitor, and we can see how the RGB values are changing. So I started out with red at 255 as the green value increases up to 255 and blue stays at 0. Then the green and blue values stay constant while the red value decreases. Then the red and green values stay constant while the blue value increases. So I'm cycling through, changing just one of these at a time to cycle through the different colors. But again, you can take the basic idea of the code here and change it to do different things. For example, you could try changing 2 variables at once in a loop to change which colors you fade between. Instead of hard-coding your LEDs to fade through a certain color pattern, you also might want to make them reactive. So there are a variety of sensors you can use with an Arduino, and we have tutorials for many of them linked in our Arduino playlist in the description of this video. So you could add potentiometers to your breadboard, just knobs you can turn to control the different colors, or you could make the LEDs react to the presence of a person using a motion or a distance sensor. You could use a temperature sensor. There are a ton of different options that you could use to make the colors change and react to different things in the environment. So we're not going to cover all of those in this video. Again, this video was just to show you how to set up and use these LED strips. But if you want to check out different tutorials for different sensors you could use or projects you could do with these strips, check out the links in the description of this video.